How to solve an NMR spectrum? There are some steps to solve the NMR spectrum, as you may see here. The first step is to calculate the number of the peaks. Number of the peaks will tell you directly that how many kinds of the protons or the carbons are present. We will solve both the C13 as well as the proton NMR spectrum. Okay, and here you will determine the chemical shift value. The chemical shift value will tell you the specific functional groups or the specific kinds of the protons or the carbons that are present. And here to find the integration value, you will find the integration value. This will tell you that how many carbons or how many protons are present inside or in the single peak area. And here you will at the last reduce the structure, that is our basic word here. So in the IR spectrum, you are watching here, that is 3458 peak. This peak is due to the OH group. As you all know that this is due to the OH group, so it means the hydroxyl groups are present in your compound. Here in the mass spectrum, as you may see here, this is your molecular formula, that is C6H14 and O2. This is very important because you can easily elucidate the structure from this molecular formula if you have known the specific functional groups as well as the specific kinds of the carbons and the specific kinds of the hydrogen. So one kind of the hydrogen that you have already known is that OH group. The hydrogens that are present in the OH group, this is one kind of the protons that are present in your compound. Okay, and here now this is the C13 NMR spectrum. In the C13 NMR spectrum, the first spectrum that is given is the depth. In the depth, the information that is given is very important, as the CH2 group gives the downward peak and the CH3 and the CH groups gives the upward peaks. As there is no downward peak, so it means that CH2 group is missing in your structure and only the CH3 groups and the CH groups are present in your structure or the CH group. But more chances is that the CH3 group is present because mostly the CH group gives us the peak value in this range almost. Okay, and now the solvent peak, that is due to the solvent, and one more peak is given here. This is very important as there is no peak shown here in the depth, and this is the proton decoupled spectrum, so it means that this peaks is due to the single carbon atoms that is not attached with any protons. So two types of the carbons here are present. One is single carbon and the other carbon is maybe due to the methyl group. So here now this is the turn for the proton NMR spectrum. Before the proton NMR spectrum, the information that we get before this is that the molecular formula of your compound is C6H14O2. So we will write here C6H14O2. And the other information that you get is that OH group is present. Other information that you get is that the single carbon is present. Single carbon is present, as well as there are the chances of presence of methyl group or the CH group. So this is the information that you get till now. And now this is our turn to solve the NMR spectrum, as you may see here. This is the integration value, scaled integration value. It may be given in the digitalized form. So it's in the digitalized form, as you may see here, the carbon 14 are present. So it means two types of the carbons are present. When we solve this, the information that we get in integration value is this peak have the 12 protons and this peak has the 2 protons. To find the integration values from this scale, first of all you will take a scale, you will measure it, and according to that you will give the protons to each peak area. Okay, here first of all the peak information that you get is almost 1.1 ppm value. This is almost value that is here, so it means that these protons are maybe due to the methyl group. Okay, here if you see here, the 12 protons are present in this methyl group. It means that 4 methyl groups are present in your structure, and the singlet peak shows that these 4 methyl groups are attached to the carbon atoms that is not directly attached with the hydrogen atoms. So it is simple. If you start here, if you attach the methyl group, we cannot attach the 4 methyl group to the same carbon atom. And the other thing that we get from this peak is that all the 4 methyl group have the same chemical environment. Okay, if they have the same chemical environment, it means towards either side there are the same groups are attached like this. Okay, 6 carbons are present. Is the 6 carbon? 1, 2, 3, 4, 5, 6. Yes, these are the 6 carbons are present. Are there 2 kinds of the carbons in this compound that we have? still now elucidate. This is one type of the carbon and the methyl is the second type of carbon. Yes, it is also correct. So these two carbons are present and the methyl groups are also present, and here OH group was also present. Okay, from the NMR spectrum, is there any chances of OH group of presence of OH group? Yes, this ppm value 3.1 ppm value, this value, and it is exchanges with the D2O, which shows that this peak is due to the OH group. So the integration values are 2, it means 2 OH group are present in your structure. So first OH group is this and the second OH group is this. So this is your elucidated structure that you get from the proton NMR and the C13 NMR spectrum. If you see here, this is the structure of one carbon, second carbon, third and the fourth carbon atoms, and here it means that 2, 3 dimethyl 2,3 hydroxyl butane, and this is also called the Pinacol.